Hey guys, welcome back to day 10 of solving LeetCode question. And as usual, we are trying to solve some question related to LeetCode. Okay, so this question is locked. Mm, Contains duplicate. I guess I have already done this question, right? Let's read the description of the question. Given an integer array knobs, return true if any value appears at least twice in the array and return false if every element is distinct. Okay, I haven't done this question. What I actually did was single number, right? Hmm. Okay, so what this question is telling us is if any of the number repeat twice, then we have to return true. Otherwise, we have to return false. Okay, so we have a array of nums consisting of integers. We have to return true the numbers are if any of the number is present twice, otherwise return false. Okay, so let's look at the topic array as table sorting. Okay, so I think what we can do is we can simply sort the array and we can just check first index to second index to third index like that, right? Okay, so for uh, int I equals to 0, I is less than nums dot size. But if we could simply sort this array, then we could compare each element with other, which will be a bit faster, I guess. But let's try to sort this array first. Plus, and there always need to put -1 in order to save runtime for for int j equals to I plus 1, j is less than nums dot size j plus plus if nums dot size sorry if nums I is greater than nums j, what we can do is let's prepare a temp variable. And what we can do is temp equals to nums I equals to nums j and nums j equals to nums I, right? Sorry, not nums I equals to temp. After doing this, our arrays should be sorted. And what we can do is for int I equals to 0, I is less than nums dot size and I plus plus, we can what we can do is if if it's all array are sorted, sorry, all the element present inside of array are sorted. So if we compare nums I equals to nums I plus 1. Okay, so what we can do is we can do I plus equals to 2, right? And if these two index are equal, then we can simply return true, is there is duplicate element present. However, if no element are present in duplicate, then we can return false. So this spelling of false is mistake. False. So what I was thinking is the topic include sorting, uh, right? Sorting. So what I did was it also include as table. Mm. So what I thought was, sorry, let's suppose we are given an array consisting of five elements, and these elements are one, two, three, four, and 1. So what we can do is we can sort this array in ascending order, right? Okay, so after sorting the array, the limits become 1, 1, 2, 3, and 4. So what we are doing is we are comparing 1 with 1 is these two elements are same, which means element are present in duplicate. So we can simply return true, right? However, however, if let's say these elements are 4, 5, 5, 2, 0, and 5, right? So in ascending order, it will be stored as 0, 2, 4, 5, and 5, right? Okay, so I have found a flaw in my algorithm. It will compare this and this, it will compare this and this will remain unknown. So what we can do is, instead of doing plus equals to 2, we can simply do plus plus. Okay, so this will work. So what we are comparing is we are comparing 0 with 2, and we are again comparing 0, 2 with 4, we are comparing 4 with 5, we are comparing 5 with 5. Yes, 5 and 5 are true, so it will, sorry, if 5 and 5 are equal, so it will return true. However, let's say this element was 6, right? If this element was 6, then we compare 0 with 2, 2 with 4, 4 with 5, and 5 with 6. Is none of the elements are present in duplicate, so it will return false. However, it will take a lot of time to execute. Its sorting is present, so let's gamble. Okay, so so uh, if I equals to norms dot size minus 1, great. However, I don't think it will, or it can handle time complexity. It will consume more time than what's required. Yeah, time limit exceeded. That's the greatest problem I am facing currently. So we have to solve this problem linearly, right? So what I want to ask ChatGPT is, uh, so previously in yesterday question, if two elements were present in duplicate, right? Uh, in this question, yesterday we did single number, right? And the question was given a non-empty array of integer norms, every element appeared twice for except for one. Find that single one. You must implement coefficient. The question was telling us that if elements are present twice, sorry, every element are present twice except for one element, and we have to return that element. And what we did was we used bitwise XOR operator, right? So what I want to ask is, uh, does XOR Later, delete all single number, leaving only duplicate number, which I don't think will happen. However, just we are just betting. No, the video does not delete all single numbers and leave one duplicate number. Instead, AXNOR operator. The bitwise AXNOR operator does not delete all single number and leave one duplicate number. Instead, AXNOR operator perform a bitwise comparison between two numbers and returns one if they are same. What happens when we compare all numbers at the same time? When you compare all numbers in a list at the same time using bitwise AXNOR operator, you are essentially performing a series of pairwise bitwise AXNOR operator across all the number in the list. The result will depend on how the AXNOR operator interacts with each number individual bits. Let's break it down. AXNOR operator returns 1 when two bits are same and 0 when the bits are different. In the context of multiple number, you apply the AXNOR operator to each. Yeah. So perform six actions, take the result of that and perform action operator with two stepwise explanation. Okay, so it doesn't do anything. So to know the result is 7 by comparing all the bits in each person. Okay, so we can solve this question like this. However, the topic includes sorting. So we need to sort this. We I wasn't trying to look at solution. I was trying to look at my solution. Okay. If we go through the array in linear path, right? Let's take our example. And if we go through this array linearly, zero, sorry, this is the given array. Okay, let's add another element and make 5, this 5. First we compare 4 with 5. Uh, this won't work. If we don't sort, then we have to compare each element, right? If there is no criteria like small element or larger element, so we can't take compare to element and take larger or smaller element. So what should we do then? We have got to do something, right? 5 and 5 are equal. It can only be found out if they are sorted. Then they would have been together, and it would be easy to find. It consists of sorting as table and array as table to sum. What is the question? Given an array of integer nums and an integer target return indices of the two. Okay, so let's about indices. Uh, Similar question. If we could sort, then we could simply compare each element, right? Like we could compare 4 with 5, 4 with 2, 4 with 0, 4 with 6, and 4 with 5. Now we compare 5 with 2, 5 with 0, 5 with 6, and 5 with 5. But it will take a lot of time and okay, so we have to look at the solution for this problem too. What the hell, man? So we have to do this only. What I thought, if the length was 10 to the power 5, we couldn't do that. Okay, so I was correct at first. Norms I equals to norms z, return true, else return false. That's what I was gonna do. But I looked here and I saw sorting, so I thought we need to sort it. Whatever. But we have 10 to the power 5 here, so I thought we couldn't do this. Yeah, we can't do this. As it will return in time complexity. But the solution actually did it, right? Yeah, I equals to 0 and minus 1. Yeah, I plus plus, I plus 1, less than size. If norms I equals norms j, return true or else return false. Where n is the length of the array. Yeah, this won't work. Actually, I did this and it won't work. So this solution is out of the picture. Sorting. Okay, so we have sort function. I didn't know that. Okay, so we have sort function in C++. It will make this a lot easier if we have sort function. Sort function is used to sort element in a container such as array, vector, or other other element. So we have sort function in C++. I thought it would only be present inside of higher level programming language like Python or Java. This function is a part of algorithm. Okay, so we need to include algorithm class. Sort array, array plus n, size of array, sort, where is sort? Listen, sorting, sort norms dot begin, norms dot end. Okay, and yeah, after sorting. So what I did was correct. Is I looked at sorting and I did the sorting. However, is it took too much time. Is that's what I thought. So what we actually needed to do was we have was a function named sort. So what we need to do is norms dot begin and norms dot end, right? Uh, After this, our array should be sorted. So we can use the loop I equals to 0, I is less than norms dot size minus 1, I plus plus, j equals to I plus 1, j is less than, no, sorry, it's just my habit. Uh, norms I equals to norms I plus 1, right? It will go up to second last element only. And if it is equal, then we will return true, else we will return false. What happened? Okay, so I didn't put int here. I didn't declare it I variable in this for scope. Okay, so it should work. I didn't know we have a function named sort. Okay, so it only gets 77. What's the best possible solution? Brute force. This won't work. Actually, I tried this right and it didn't work. Yeah, I used sort algorithm too. Okay, so it is analog and complexity. Set applets. Return non-start size less than set in non-start begin comment. To so it has a complexity of n. What is it different? As map on order map in okay, I don't know this algorithm, so one step at a time. What we have to do is solve each question one step at a time. So that's solved today's question. And is yesterday I was learning about linked list. Actually, I only looked at the description or explanation of the linked list yesterday, and what I did was I learned it off camera, and now I know how to create a linked list in our program and how to actually implement it. Actually, I learned to create a I learned how to create a linked list. I learned how to display the element within inside of linked list, right? I learned how to add element at the end of the linked list and also learned how to add element at the beginning of the linked list. Okay, so after this, we'll move to next step. Okay, sorry. Uh, Actually, this is the website I made as a fun little project. Here we can play a card game. Uh, what we have to do is we have to match similar cards. Uh, if two cards are same, then they will disappear. Yeah, I think this card was same. Yeah, so this was same, and this will be same. If we win, it will show how much time it took for us to complete the game and how much try did it took. And that's the game I made. You can check this game. I will link this game in the description or link the website in the description. And I will also link my GitHub link. You can visit. I haven't made that much big project, but I'm trying to create I'm trying to create new project every week or every month, and I try to code each day. You can uh, catch up at what I'm doing in present day there too. I'll try to update you too about what I'm doing and what I will do in future too. Okay, so let's try to move it new concept. Try to learn new concept. Mm, Yesterday we Yeah, we try to learn linked list, linked list, this for this. I completed yesterday task, so let's move with new concept. I learned singly linked list, and I also learned the concept of doubly linked list, linked list, doubly linked list and circular linked list, but I don't know how to write their code. I learned to link list insertion at starting and at its beginning. Searching will be easy as it is similar to inserting element at end, right? Uh, we can delete too. I think I can do that, but I haven't tried this one in the middle of the link list. I'll try to learn new concept instead, and I'll try to inform you guys what I have learned today. Okay, so I could actually do the program and solve the question or solve. Uh, okay, so I'll do that. Then let's use an online compiler for C++. Let's use a programming. I'll show you what I learned about linked list. Start. Okay, is we don't have a built-in class for linked list in our C++. We need to create a class ourselves. What I mean by class is that is we learned yesterday in linked list we create a or we create multiple blocks which has two partition. One is for storing value and another is for storing pointer, right? So uh, actually we also require an additional pointer named head, which point at first pointer. After that, this pointer will point to next block or next node, and this node will point towards next node, and the last node will always point null, right? So what we have to do is we have to create a class name node. It can be named anything. However, I like to name it node. And we need to use public access specifier as we have to access this data member of data data member of this class from external scope. First of all, we have to store value, and another one is we have to store a pointer, right? And the pointer type is node, which is the class we are just creating because this pointer is pointing towards next object of this class, right? And we need a constructor for we need a constructor for storing the value, which we will assign, sorry, which we will assign it val, right? And let's create our main function. I'll try to go through insert at beginning, insert at end, serially, okay? So what we have to do is we have to create a node pointer named head, which is uh, empty at first, as we don't have any means to insert element or display element. We can do nothing, so we can just return zero. So this code will do nothing, right? If we run this program, then nothing will happen. Code execution successfully, as we haven't done anything, so it won't do anything. Just a pointer of node type will be created named head, which is pointing towards null. It is pointing towards nothing, so nothing will happen. So what we can create is we can create a display function for displaying the value present inside of uh, the class. And what it will do is we need uh, we need to access it inside of display is I already told that we need head pointer which is pointing towards first node, right? So in order to print the data present inside of linked list serially, we require head pointer at first, right? So what we can do is we can create a pointer named temp, which is which takes the memory block which is pointed by head, and what we can do is we can use while loop to say if temp is not equals to null. So what we are trying to do is unless the temp is pointing towards null, the loop should continue and move forward, and we have to print. We have to what we have to do is we have to print uh, the value present inside of the value present inside of sorry, we have to print the value present inside of, or sorry, the we have to print the value which is pointed by the uh, temporary pointer. What I'm trying to say is, let's say this is our temp pointer which is pointing towards this second memory block. So what this statement will do is it will print the value. It will print the value present inside of the temp value, which is equivalent to printing the value. uh, This one, equivalent of printing this value. Sorry, I should delete this tab. And after that, we have to shift. So we have this pointer. We have to shift this to. Okay, I think this is opposite. Temp should point to next pointer, right? So what this is doing is after after printing this value, if there is another node, then this pointer will point towards this node, right? So we are assigning this address to temp. So this temp will point towards new node. So unless the unless the node is pointing towards null, unless the node is pointing towards null, it will continuously print the value. So this is a display function. Another function what we need is insert at insert at beginning. It will take two parameters. One is head pointer, which we are making a reference pointer, and another we need value, right? So what head will do is head will store the address of current head, which can be null or which can be if there exists or not, then it will point towards first node, right? And we always require insert at beginning for storing the first value. Uh, and what we do is we create a uh, we create a an object of node class using dynamic memory allocation using new operator, new node, and we are triggering the constructor, and which will take the value which is inside of value. Okay. So temp will uh, so what we can do is the the new the n pointer will the sorry the pointer present inside of n will take the address present inside of head, right? And head will store the address of n. So what we are doing is, suppose if this was our current first block, so what head will do is head will store the address of this memory block, right? So what if we want this node to be our new head. So what we are doing is we are storing uh, or the pointer inside of this node will store the address present inside of head. So it will point here, right? So after it points here, so what we can do is we can the head will point towards this memory block, right? So our new head will be this memory block. Sorry, our new head will be this node. It's now head is currently pointing towards this node. That's what we are doing using insert at beginning. And another function we require is insert at end, right? What insert at end will do is it will insert next memory block, or it will insert next node. If we have to use standard language, we need to say node. But what we are doing is we are inserting memory block is we are creating a new memory block using dynamic memory allocation. Node and equals to new node value, just like we did in insert at beginning function. And what we require is we actually require a temporary pointer for storing the address present inside of it. After this, what we do is while the address present inside of a current temporary object is not equals to null, unless it is null, what we have to do is now this pointer or this temporary pointer should point towards the pointer present inside of temporary pointer. I know this sounds a bit confusing, but what we are doing is suppose this is our current node and this is our next node, right? So the pointer present inside of this current node will point towards this next node, right? And our current temporary pointer is pointing towards this memory block or this first node. Let's name this N1 and name this N2 for better understanding purpose. So as temp is pointed towards N1, what we are doing is we are assigning the address present inside of N1 PTR N1 PTR here, right? So now so now temp consists the address present inside of N1 PTR, which is actually the address of this memory block. So it will point toward this memory block. So we are simply shifting the address present inside of temp from N1 address of N1 to address of N2. That's what we are doing, right? After doing that, uh, suppose this pointer point towards null, right? So after doing this, the address present inside of here will be assigned to temp, which is actually equals to null. So sorry. So if it is equals to null, so if it is equals to null, then the given condition will be false. Is the condition is not equals to null, and if it is equals to null, then the condition will be false and will exit out of while loop. So it means that we are at last block, right? And what this function is trying to do is it is trying to insert a node at the end of the linked list, right? So if this is our desired node which we want to insert at end, so now this pointer should point towards this node, right? So what we can do is we can simply tell the current temp pointer to point towards this new node, right? So what we are doing is we are accessing as temp is currently accessing this memory block, so we can simply use temp arrow operator, temp arrow operator PTR, right? And as PTR is currently storing null, we are assigning this null to N3. And as N3 is a memory block which is created using dynamic memory allocation, so we are accessing the address of this memory block which is being stored here, right? So what we can do is, okay, why am I not being able? I believe I can use, yeah. So we always have to insert at beginning. We always have to use insert at beginning. And if we try to use insert at end, there is no memory block. So the head is currently accessing null. So this loop will always be false and no memory block will be accessed. So we always have to use insert at beginning first. Let's say this to store one, right? Now you can simply uh, insert it, insert it in for storing two. Let's try to insert up to five. Insert it and add. See, actually, what I can do is I can simply copy this and paste and paste. This is 4 and this is 5. See, uh, first of all, we are inserting at beginning, so this will display 1. It won't display actually, it will only allocate as we are not triggering display function or calling display function. After that, we are inserting at end, then end, then end, then end. So it will create a linked list which will be linked in this way 1, 2, 3, 4, and 5. So what if I try to insert another element at beginning, right? So if we do that, then our current head will try to point towards uh, this. Okay, so the object storing 0 will be our new head instead of this one, right? So let's use display function. We always have to pass head in our display function. We always have to pass head in our display function as we require the pointer pointing towards the first object in order to display. So let's run this code and see if I have done any mistake or not. If I have, yeah. So it printed 0, 1, 2, 3, 4, and 5. As I inserted 0 at the beginning at last, so 0 will be our new head. Sorry, not head. It will be first node. Then 1 will be our second node. Then 3, 2, 3, 4, and 5. Yeah, I learned this much today. So tomorrow I will try to learn doubly linked list and I will try to update you guys too. Okay, so thanks for watching. Be sure to like, share, and subscribe. And I will try to upgrade my skill related to this function too. So what I want to do is I want to create a note in certain website. I don't know which website, but I'll try to find a website where we can store or we can save this type of new function which we learn each day. And after few days, we can uh, revise this function and try to remember them. Okay, which will help us to improve our skill. So that's it for today. Thank you for watching. Be sure to like, share, and subscribe. I'll see you tomorrow.